So today what we are planning to do is look at the first tutorial, which is tutorial agent team. Build your first intelligent agent team. So let's see what this is about. I think this should give us an idea of how to build the end-to-end agent and what will it look like, right? So cool, sounds interesting. Let's see what we have. Let's just go over this, right? So this tutorial extends from the quick start example. Now you're ready to dive deeper and construct a more sophisticated multi-agent system. We'll embark on building a weatherbot agent. Okay, progressively layering advanced features onto a simple foundation, starting with a single agent that can look up weather. We will incrementally add capabilities like leveraging different AI models, designing specialized sub agents for distinct tasks like greetings and farewell, enabling intelligent delegation between agents, giving agents memory using persistent session states, implementing crucial safety guardrails using callbacks. Okay, so a lot of things will be happening here. All right, via weatherbot team. Okay, this use case, while seemingly simple, provides a practical and relatable canvas to explore core ADK concepts essential for building complex real-world agentic applications. Okay, fine. What is ADK again? Okay, that we already know. So in this advanced tutorial, you will master a lot of things basically. ठीक है ये सब तो and state by completing this tutorial you will have built a functional multi-agent weatherbot system. Okay, crucially completing. Okay, API keys. Okay, note on execution environment. uh, what is this? This tutorial is structured for interactive notebook environments like Google Colab Enterprise or Jupyter Notebooks. Okay, please keep the following in mind. Running async code. Notebook environments handle asynchronous code differently. You will see examples using await suitable when an event loop is already running, common in notebooks, or async io.run, often needed when running on a standalone Py script or in specific notebook setups. Okay, the code blocks provide guidance for both scenarios. Makes sense. Manual runner and session setup. This step involves explicitly. ठीक है, सो एक तो है कि रनिंग async code we have to figure out how to run it on our standalone machines. That's fine. And manual runner session steps. The setup involved explicitly creating a runner and session service instance, which I have no idea what these are. I think we will find out. This approach is shown because it gives you fine-grained control over the agent's execution lifecycle, session management, and state persistence. ठीक है, so we might be creating a runner and a session service, but I have no idea what that is. ठीक है, let's see. Alternative, using ADK's built-in tools. If you prefer a setup that handles the runner and session management automatically using ADK standard tools, you can find the equivalent code structure for the purpose here. That version is designed to be run directly with commands like ADK web. ठीक है, we'll skip that for now. Ready to build your agent team. ठीक है, तो अभी तक तो I have no clue what we are getting into, but most probably we will soon find out. Alright, so alright, let's get started. Let's see what this is about. Right, so I think it's better if we create a new project. Right, so let's create ADK tutorial iCham projects. ठीक है, not required, pure Python. Alright, cool. They created a virtual environment as well. I always prefer. ठीक है, this is our terminal. Okay, which Python 3. ठीक है, cool. So virtual environment is already there. We will need to install Google ADK. Let's install that. No, not this. Where is our? Okay, this one. ठीक है, ये इंस्टॉल होगा. फिर pip install light llm -q. Okay, what happened? Find a version that satisfies the requirement installing this. Okay, new lease. Hold on. Did it install or not? What does minus q do? Minus q. Let's check this. Quiet. Okay. Opposite of verbose basically. ठीक है. I'm not really sure. It's taking more time than I expected to. काम करते हैं. Terminal खोलते हैं. Okay. अच्छा. Okay, I think it's installed. Let's see. Pip freeze. Hold on 1 second. Pip freeze. Pip let it. ठीक है. ADK. नहीं, so ADK did not get installed. ठीक है. तो अपने को ADK इंस्टॉल करना है अभी. Let's install ADK. I don't think I prefer minus q. कुछ पता ही नहीं चलता है what is going on. ठीक है. let this complete and meanwhile installation complete हो गया. ठीक है. उसके बाद importing a lot of things and ठीक है. तो ये तो हम ऐसे ही import कर लेते हैं for now. So for this new directory, actually Python package home new agent.py. क्या प्रॉब्लम है? import. ठीक है, देखते हैं इसके. ठीक है. वार्निंग्स है, लॉगिंग है. ठीक है. गूगल API now. I think Google Studio keys API keys. Get API key. Create. Copy. And we have to paste it like this. ठीक है. तो voice.env इसको हम .env में डाल सकते हैं ना फिर. .env या भी ऐसे ही डाल देते हैं. alright, so इसको what we can do is just this. ठीक है. Cool, this makes sense. Now I don't think we need others right away. All these are optional. ठीक है. API keys are set. Google API key is this. Printing API key is fine. configure ADK to use API keys directly, not Vertex AI for this multi-model setup. ठीक है. What next? More supported models can be refreshed. ठीक है. Okay, I'll just copy paste this as well. Alright, your first agent, basic weather lookup. Let's begin by building the fundamental components of our weather bot, a single agent capable of performing a specific task. ठीक है. So we are building an agent. Okay, component of a weather bot. तो एक weather bot है और उस a single agent capable of performing. ठीक है. Weather bot is our agent. Okay, looking up weather information. This involves creating two core pieces. ठीक है, a tool and an agent. A tool is a Python function that equips agents with the ability to fetch weather data. Okay, an agent, the AI brain that understands the user request, knows it has a weather tool and decides when and how to use it. ठीक है. तो ये हमारा, this will be a Python function, and an agent is basically the one that understands the request and then figures out how to use the tool. Okay, all right. Then define the tool get weather. In ADK, tools are building blocks that give agents concrete capabilities beyond just text generation. Okay, they are typically regular Python functions that perform specific actions like calling an API, querying a database, or performing calculations. So basically, tools are Python functions that do things that mostly we will be writing. First tool will provide a mock weather report. Okay, mock. So basically, not a real one. Okay, this allows us to focus on the agent structure without needing external API keys yet. Okay, later you could easily swap this mock function with one that calls a real weather service. Okay, key concept. Doc strings are crucial. The agent's LLM relies heavily on the function's doc string to understand. Okay, what the tool does, when to use it, what arguments it requires. Okay, best practice, right? Clear and descriptive and accurate doc strings for your tools is essential for LLM to use the tool correctly. So basically, these doc strings are very important. So what I am going to be doing is typing it all out so that it's easier for me to follow, right? Because I would like to know what I'm doing. So let me type it all out. इसको ऐसे सेटअप करते हैं अपन. This, okay, this needs to be smaller so that I can do this and this, right? So I'm just going to type the whole thing out here. So what is it asking me to do? You here get weather. ठीक है. So this is, we are writing a tool here, right? Def get weather city stir date. Okay, doc string retrieves the current weather report. Okay, for ठीक है. So the reason I'm typing all this out is so that I can process it as well, because I am doing this for the first time, so I don't really know what is going on. So basically we are writing all this out so that the LLM can understand exactly what this function will be doing. Okay, the name of the city. ठीक है, this takes the name of the city. Example, New York. ठीक है. London or Tokyo. Alright. Tokyo. Okay. Returns a dictionary containing the weather information. Okay, includes the status key success error. Okay, success key success or error. Okay, makes sense. If error includes an error message. Okay, if error includes an error message key. Okay, ठीक है, makes sense. So the doc string ends here. What next? Print tool get weather. Acha, this is just printing. F tool call for city. Okay, city normalized, city dot lower dot replace. Okay, so this is basically they're cleaning up the information that is being sent. They're removing all the spaces and they are converting everything to lowercase. Okay, then mock weather db. Okay, I'll just copy this bit. This is the mock weather database and all these are normalized. Okay, then if city normalized in mock weather db, return mock weather db city normalized. Okay, else throw an error most probably, right? Return status is error message. Sorry, I don't have weather information for the city. Okay, I don't have weather information for this city. Got it. Alright, so that's what our tool is. Alright, this will get a city as an input and then give you some weather information. Alright, makes sense. Define the agent. Now let's create the agent itself. Okay, an agent in ADK orchestrates the interaction between the user, the LLM, and the available tools. So there are three folks. One is the user that will be using whatever we are building. Let's create an agent itself. Okay, the LLM and the available tools. So LLM is the large language model that we will be using and the available tools. Okay, so LLM plus tool and the agent is helping the user use these tools together. Okay, we configure it with several key parameters. Name, a unique identifier for this agent. ठीक है, agent का नाम. Model that will be used by the LLM, makes sense. Description, a concise summary of the agent's overall purpose. This becomes crucial later when other agents need to decide whether to delegate tasks to this agent. Okay, ठीक है, इस agent का description and instructions, detailed guidance for the LLM on how to behave, its persona, its goals, and specifically how and when to utilize its assigned tools. तो ठीक है, so instruction is the instructions embedded inside the agent which will be moved on to the LLM so that the LLM can behave in a certain way that the agent expects it to behave like. Okay, tools, the list of tools that this agent slash and the LLM have with them. ठीक है, okay, provide clear and specific instructions, instruction prompts. ठीक है, so instruction is basically the prompt. Best practice, choose descriptive name and description values. Okay, so here I think we are defining our agent model is model Gemini Flash. Okay, weather agent is agent. Okay, it has a name, agent v1. model is agent model. ठीक है, तो इस एजेंट को we are giving a name, we are giving the model that the agent will be using, description, provides weather for information for cities. Okay, instruction. Okay, so this is the prompt. You are a helpful weather assistant. Okay, when the user asks for weather in a specific city, when a user asks for the weather in a city, use the get weather tool to find the information. Okay, makes sense. If the tool returns an error, inform the user politely. Okay, so all these instructions will go to the LLM and that's how it's going to behave. Okay, if the tool returns an error, inform the user politely. If the tool is successful, present the weather report clearly. Okay, these are the instructions that we are setting this agent up with. Okay, and then we are providing the list of functions that can be used by this guy. Okay, so we have given the functions directly. Makes sense. Okay, the agent is defined now. Print agent weather agent dot name created using model agent model. ठीक है. Okay, set up runner and session services. To manage conversations and execute the agent, we need two more components. Session service responsible for managing conversation history. ठीक है, so we need a session service. Let's also keep making notes. Right. Alright, so there is something called session service and there's something called runner. What are these guys doing? Responsible for managing conversation history and state for different users. Conversation history and state. Conversation history and state and session for different users. Okay, in memory session service implementing everything in memory. Okay, so the in memory session service is a simple implementation that stores everything in memory, which makes sense. Then keeps tracks of messages exchanged. So basically session service will be required. This is the one that maintains the session, conversation session. History of sorts. Okay, what's a runner? The engine that orchestrates the interaction flow. Okay, it takes in user input, routes it to the appropriate agent, manages calls to the LLM and tools based on the agent's logic, handles session updates via the session service, and yields events representing the progress of interaction. A lot of things this guy is doing. So this is the orchestrator. This is the orchestrator. orchestrator. Okay, calls to LLM, calls to tools. What else is it doing? Storing things in session using the session service. Okay, what else is it doing? Session updates, takes the user input, takes in the user input as well. ठीक है. And yields events representing the progress of the interaction. ठीक है. So this is basically the orchestrator, the manager of sorts. Okay, so all right, going forward, let's create a session service. Session service. Yes. And memory session service. Okay, what next? Define constants by identifying the interaction context. Okay, define constants for identifying the interaction context. App name, weather tutorial app, user ID, user 1, session ID. ठीक है. So these are just constants. ठीक है. Session W1. ठीक है. Okay, now create a specific session where the conversations will happen. So we are creating a session await session service, create session, app name, user ID, session ID. Okay, we're getting this error. We'll come back to this in a bit. ठीक है. Print. So we have created a session. Created app name, user ID, okay, this is just printing. ठीक है. Key concept: runner orchestrates the agent execution loop. All right, so runner is the main guy here. We are creating a runner. He is taking the agent, which is the weather agent. So we want to run the weather agent. And what is an agent? An agent has a name, it has a model, it has a description, the instructions, and this. So agent is a wrapper that wraps the LLM and the tools. ठीक है. And a runner will use the agent, which is a wrapper on the LLM and the tools, and it takes an app name and it takes the session service. ठीक है. So this is a session service. No, not the session. It will use this particular session service to use this weather agent. So session service plus weather agent and an app name. That's what a runner is. Okay. Printf runner created. Okay. Interacting with the agent. We need a way to send messages to our agent and receive its responses. Since LLM calls and tool execution can take time, ADK's runner operates asynchronously. Okay, so the whole thing runs asynchronously. Makes sense. We'll define an async helper function call agent async that takes a user query string, packages it into the ADK content format, calls runner.run async, providing the user session context and new messages. Iterates through the events yielded by the runner. Through the events yielded by the runner, events represent steps in the agent's execution. ये नहीं समझ आया, 1 second. So we need a way to send messages to our agent. ठीक है, agent the wrapper on top of LLM and the tools, and receive its responses. ठीक है, since LLM calls and tool executions can take time, of course, ADK's runner operates asynchronously. Alright, then we'll define an async helper function call agent async. Okay, and maybe give it to the runner or something, so it will, or not really. So this guy might use the runner. Let's see. Takes a user query string. Okay, this function takes a query string, packages it into some format, calls runner.run async. Acha, so it will call runner with the ADK content converted query string, providing the user session context and the new message. Okay, iterates through the events yielded by the runner. So the runner will return a list of events. Events represent the steps in the agent's execution. Example: tool call requested, tool result received, intermediate LLM thought, final response. Okay, identifies and prints the final response event using event.is final response. Okay, so this guy will call runner and read through all its events and then print the final event. Okay, makes sense. Why async interactions with LLMs and potentially tools like external APIs and IO bound operations. Using async IO allows the program to handle these interactions efficiently without blocking execution. Okay. So basically from google.genai import types for creating message content or paths. ठीक है, async def call agent async query store runner user ID session ID. So takes a session, a runner, a user ID, and the query string. So runner, okay, and a user ID. I don't know what's the use of this, but take care. Then what does it do? Print user query okay. Prepare the user's message in ADK format. Okay, prepare the user's message in ADK format. Content types dot content role user paths types dot part text query. So this is where the user query is getting converted into types dot content type, and then final response text agent will not produce final response, the default one. ठीक है, then async for event runner dot run async user equal to and new message. Okay, so what we are doing is, this is an async for loop. Okay, so run async, which takes a user ID and a session ID and the message. So this message will be executed inside the session. Okay, and the session service is embedded inside the runner. It gives us a list of events. Okay, and what are we doing with that event? If you can uncomment the line below to see all the events. Okay, else if event dot is final response if event dot content and event content dot parts final response text event dot parts of 0 dot text. Okay, elif event dot actions and event dot actions dot escalate final agent escalated. Okay, there's like an exception, I think. Event dot error message or no specific message or no message. Okay, or no specific message. ठीक है, तो I don't think there is anything here, and then we are breaking at this point. So if it is a final response, then we do things and then we break, and then we are printing print agent response final response test. ठीक है, okay. Cool, ठीक है. So run the conversation. Finally, let's test our setup by sending a few queries to the agent. We wrap our async call in a main function. Okay, watch the output. See user's query. Notice the tool get whether call logs when the agent uses the tool. Okay, async def run conversation await call agent. What is the weather like in London? Runner is equal to runner, user is equal to user ID, session ID equal to session ID. Okay, so now we have to call this await run conversation. Okay, or uncomment the following lines if running as a standard Python script, which we are. So this is how we run async. Okay, run conversation. So this is running this, but I think, okay, let's see. Okay, create session. This cannot be outside, so we need to create this session inside. let's create this session first here. Create session. Def. Right. So first we do so a session gets created with this particular session ID. Why not? Okay, for now we'll just use it. It's very badly written code, honestly, but okay. Let's see what async IO actually does. What does async IO do? Programs would use this IO bound operations without using multiple threads and process. Okay, but if we want to await, it will do an await, right? No, I think it will create different thread which we don't want, so it's better if we do it like this: await, create session. Okay, so we created a session. Let's see. Not open SSL warning. Let's wait. Okay, a lot of things have happened. Google Key API status, yes. Environment configured, agent created using this, session created. Okay, runner created for agent. User query, what is this? An error occurred. Run async got an unexpected keyword argument user. Run async got an unexpected. Acha. User ID, I think. What user ID? Yeah, it was user ID. Is final response. Okay, we have a spelling mistake. Is final response. Okay. Get weather, call for city London. The weather in London is cloudy with a temperature of 15 degree. Great. So some things have happened. We did get a response from our DB. So I think what happened was, first LLM was sent, this query was sent, and then this particular city was then sent to the tool, and then tool read London, and then from there it got this answer. Pretty interesting. Okay, there were other things as well that were happening that we could have done here. Let's copy these and see how they behave. Great. How about Paris? Sorry, okay, so because our DB did not have things about Paris. Great. New York, sunny, perfect. So it is able to, interesting, a lot of things. So basically, what the ADK is doing is it has something called a runner, which is a wrap, which has an embedded session service inside it, and so a runner is made up of an agent and a session, and an agent is made up of the LLM calls and tools, and then we have written an async function which basically uses the runner, takes the query and gives it to the runner over here. Okay, and so basically we taken a string, convert it into whatever the ADK understands, sends it to the runner sends it to the LLM and the tools, sends it back, and then this function is reading the final response and printing it. So agent response is the final thing. The weather in New York is sunny. So agent response is what this tool is sending back somewhere over here. Where is our tool? City. So status, acha. So the tool actually is sending New York status success and report. This what the LLM is doing is also picking out the right thing to send. So the agent is just responding with this report. Perfect. It's not even giving us this JSON. It is just giving us this data. That is pretty awesome. A lot of things are happening behind the scenes. Great. Okay. So after this, if I look at it, then going multimodal with LLM Lite optional. This looks something new. Let's look at it in the next video. Thank you, everyone. See you.